Example 1. Sam's mother has entered a 10K race. Sam and his friends want to show their support of their mother, but they need to figure out where they should go along the race course. They also need to determine how long it will take her to run the race so that they will know when to meet her at the finish line. Previously, his mother ran a 5K race with a time frame of 1.5 hours. Assume Sam's mother ran the same rate as the previous race in order to complete the chart. Create a table that shows how far Sam's mother has run after each half hour from the start of the race and graph it on the coordinate plane. Then answer the following questions. So to help you out so you don't have to copy this table and graph into your notes, make sure you pick up a notes page which has a table and graph for example 1, and it has the table and graph for example 2. And you can cut those out and put them in your notebook if you would like. All right, so we are going to start with filling in what we know from our problem into our table. I'm going to try to zoom in just a little bit so you can see that table and graph. It's a little small. All right, let's use this one. All right, so from the table, I know that I need to, create a table that shows how far Sam's mother has run after each half hour. So I'm going to go through on my time and list in every half hour. So 1/2, 1, 1.5, 2, 2.5, 3. And they also told me that his mother ran a 5K race with a time of 1.5 hours. So I know at 1.5 hours, Sam's mom can run 5K or kilometers. Now I'm going to use this information and see what I can fill out here. I know if I were to double this, so if she runs for double the amount of time, that she would run double the amount of distance. Now I'm going to use this information and I'm going to divide so that I can figure out what my unit rate is, or for every one. So to do that, I'm doing distance to time. Now remember, I've talked to you guys about making sure that you write out your ratio and what you're doing. This is like our cheat so that we make sure we get our numbers in the right spot. So from my table, I know my distance is 5 and my time was 1.5. All right, so to solve this, I need to change my mixed number into a improper fraction. So 5/2 times 1 is 2 plus 1 would be 3 over 3/2. Now to divide my fractions, I'm going to keep my 5/1, change from division to multiplication, and then we're going to flip this upside down and use the reciprocal. And now I can multiply straight across. So 5 times 2 is 10, and 1 times 3 is 3. Now I can leave my number like this, and as well I'm going to go ahead and simplify it in the box. So I have 10/3, which is equal to, I know, oh, wrong box, helps if I write in the right spot, 1, not a half. There we go. I know that 3 goes into 10 3 times, and that would be 9, so I'd be left with 1. All right, so now that I have this unit rate, I can use this. Let me scribble out again. I can use this to help me fill out the rest of these empty boxes. So I'm going to get a piece of blank paper here. All right, so I know that I'm finding distance to time. I'm trying to get my numbers off here. So my distance is my y and my time is my x. And I know that that equation would be y equals my unit rate, 3 1/3, x. Or if you wanted to leave that as that improper fraction, 10/3x. So you could use that version as well. All right, so I'm going to solve for row 1. Get this where you can see it here. Okay. Row 1. I know my time is a half hour, so my time is an x, so my x is going to be 1/2. So I'm going to use my equation, but I'm going to replace that x with my 1/2. Sorry, make sure you can see it. Y equals, I'm going to use the 10/3 times 1/2. Now I used the 10/3 because I know I was going to have to multiply. All right, so when I multiply, I get 10 times 1, which is 10, and 3 times 2, which is 6. And then I can divide these both by 2 to simplify, and I get 5/3. So in half an hour, Sam's mom will run 5/3. All right, so I'm going to do, row 1, 2, 3. Let's do row 4. All right, so my time in this case is 2. And we're going to do the same thing. So we're going to go 10/3 times 2/1. When I multiply, 10 times 2 is 20. 3 times 1 is 3. So this would be 20/3. Which, let's see, 3 goes into 26 times. That would be 18, and I'd be left with 2. All right, so now I'm going to do row 5. And in this case, my time is 2.5, which I'm going to make an improper fraction. 2 times 2 is 4, plus 1 is 5, so 5/2. We're going to do the same thing and use our equation. So y equals 10/3 times 5/2. All right, when we multiply, 10 times 5 is 50. 3 times 2 is 6. I know these are both evens. I'm going to go ahead and divide them by 2. So that gets me 25/3. That in my table. 25/3. Let's see. 3 goes into 25 8 times. 8 times 3 is 24, so I'd have 1 left over. Now that I have my table filled in, now I can go and graph on the coordinate grid or coordinate plane. All right, so if mom doesn't run at all, she goes nowhere. And then a half an hour, and then up to 5/3, which is like 1 2/3, so just below that 2 line. At 1, she's at 3 1/3. And when you're doing these, just get as close as you can. There's going to be some human error. It's not going to be exact. 1 1/2 and 5. 2 and 6 2/3, just kind of below halfway. 2 1/2, 8 1/3, so just above the line. And then 3 and 10. So let's see how close I got. There we go, there's our graph. All right, so now we're going to use our graph to answer some questions. What was Sam's mother's pace? Focus back in, camera. What was Sam's mother's pace throughout the race? Well, from our table, if we're talking about her pace, we would be talking about her distance per hour or her speed. So that's where we find in 1 hour she went 3 1/3 kilometers. So her pace or unit rate, so we'll say pace also means unit rate, was 10/3 kilometers per hour. Okay. What are some specific things you notice about this graph? So if we go to our graph and we look at our picture, what are some things that we notice? Well, I hope you notice that this is a straight line, and I hope we also notice that it goes through 0, 0. So it is straight and goes through 0, 0. Okay. Our next question. What is the connection between the table and the graph? So if we go back to our table and graph, the connection is that we are graphing this table onto here. So the data is the same thing. Notice that our time that's in the X column is also on our X axis, and our distance, which is on the Y column, is also on our Y axis. So let's say time is on the X axis, distance is on the Y axis. We could say there's 1, there's 2, there's 3. We could say the graph is a picture of the data from the table. Okay. All right. What does the ordered pair 2, 6 2/3 represent in the context of this problem? So if we look at our graph, if we go over 2, that's talking about time. So that would be 2 hours. Sam's mother runs 6 2/3 kilometers. So in 2 hours, Sam's mother runs 6 2/3 kilometers.